Take a moment to ponder glass. What comes to your mind? If we had to guess, we would say that you thought about a transparent, fragile material made by melting sand and some other chemical components. Although not wrong, this view is incomplete from a more rigorous scientific point of view. For material scientists and engineers, glass is a material that is in so-called metastable condition, or out of equilibrium. Being out of equilibrium means that the material's atoms are in a non-ideal situation, either stretched, compressed, or with missing bonds altogether. Sometimes the atomic arrangement of atoms in glass is compared to the atomic arrangement observed in the liquids, leading to the question, are glasses fluid? In this video, we will answer the question and show you that it is all a matter of time. In order to make the question more appealing, let us tell you a tale. While studying window glasses, like the ones from old European cathedrals, researchers all around the world found that their bottom was thicker than their top. A possible explanation for the fact is that centuries might have been enough time for glasses to behave as fluids, and the mass on the top of the window flowed to the bottom. The resistance of fluid to change its shape is called viscosity. At normal conditions, water has a low viscosity, while honey has a high viscosity, as seen here. Temperature can affect fluid's viscosity, and we observe that with glass. Glass blowers, in order to design and create their beautiful art, need to heat up their material, change their shape, and then bring it back to room temperature. In order to solve this riddle of glass, Professor Edgar Zanato from the Material Science Department at the Federal University of San Carlos, Brazil, extrapolated the behavior of glasses at room temperature to high temperatures, and was able to calculate something called relaxation time, or simply the time necessary for a particular disturbance to be significant. In this case, the disturbance is the flow of mass. In his work, Professor Zanato estimated that the time needed for glass to flow at room temperature would be at least 1 billion times larger than the age of the universe itself. That is a really long time. From this result, it is clear that the difference of thickness found in ancient window glasses is due to the fabrication method and not due to any glass flowing. Nonetheless, our question persists. Even if it takes an eternity or 1 billion of eternities for glass to flow, it still would. So, is glass a fluid? A solid is characterized by structural rigidity and resistance to a force applied to the surface, while a fluid is anything that continuously deforms under an applied shear stress. Please notice that in none of the two definitions time is taken into consideration. So, if someone has all the time in the universe, and then some more, they might call glass a fluid. But in our daily lives, we will never be able to change the shape of glass, at least not at room temperature.